Okay, now let's introduce ourselves to the basic terminology of graph. So we represent this as a node, and it can be anything. It can be landmass as we saw in the previous example, or it can be anything which is connected to other things. Okay, and say this is city A and this is city B. The way we represent them that they have a path is by joining it using an edge. This is called an edge. So right now it means that there is a path from A to B and from B to A. And so such edges are called undirected edge. Say suppose there are two cities C and D, and we represent an edge like this. That means there is a path from C to D. Like you can go from C to D, but you cannot come back from C to D using the same edge, because there is only one way path. So this is called directed edge. Now let's come back to the way. Now let's come back to how we represent a graph. Graph representation. Okay, so let's say we have a graph consisting of three nodes A, B, C, and there is an edge from A to B and A to C. So how can we represent this graph? So there are two ways to represent a graph like that. First is adjacency list. In adjacency list, we store all the neighboring or all the nodes that we can directly visit from a node. So for above problem, we can say that from A we can visit B and also C. Similarly, from B we can visit A, and from C we can visit A. So this is adjacency list. Now we can also represent it as a adjacency matrix. In adjacency matrix, we create a map which has value 1 only at those positions where there is a path. So this means there is no edge from A to A, but there is an edge from A to B, and similarly there is an edge from A to C. There is an edge from B to A, but there is no edge from B to B, and there is no edge from B to C. This means there is an edge from C to A, there is no edge from C to B, there is no edge from C to C. Okay, so this was the mathematical representation. In the next video, we'll see how can we represent these as a code. Thank you.